Today, we are diving into the invisible grid that wraps around our entire planet. It's this amazing system that we all use every single day, most of the time, without even realizing it.
But let's start with a puzzle. Seriously, think about this for a second. Imagine you're in a boat in the middle of a huge, empty ocean. There are no streets, no landmarks, just water in every direction. How would you possibly tell someone your exact location? It sounds impossible, right?
Well, for hundreds of years, this wasn't just a puzzle. It was one of the biggest, most dangerous challenges for sailors and explorers. And the solution they came up with was just brilliant in its simplicity. They decided to draw a grid, a set of imaginary lines over the whole world.
Okay, so let's break this grid down. First up, we have the latitudes. The best way to picture these is to think of them as the horizontal rungs on a giant ladder that wraps around the Earth, letting you measure how far up north or down south you are.
So what are they? Latitudes are these imaginary horizontal circles that run parallel to each other. You can think of them like a stack of invisible hula hoops, getting smaller and smaller as they get closer to the poles. And their entire job is to measure your distance in degrees from one very important starting line.
And that starting line, of course, is the equator. This is 0 degrees latitude, the big one right in the middle. It perfectly divides the Earth into the northern and southern hemispheres. Everything starts here. Now, these lines aren't just for navigation. They have real-world effects on our climate. If you go 23.5 degrees north or south of the equator, you reach the tropics. The Tropic of Cancer in the north and Capricorn in the south. These mark the farthest points where the sun can ever be directly overhead.
And what happens if you keep going all the way to the very top or the very bottom of the planet? You eventually hit 90 degrees north or 90 degrees south. You've reached the poles, where those giant latitude circles finally shrink down to just a single point.
And here's the biggest takeaway from all this. That simple 0 to 90 degree system is what creates the Earth's major climate zones. You have the super hot torrid zone between the tropics, the mild temperate zones where most of us live, and then the incredibly cold frigid zones near the poles. So these imaginary lines create very real weather.
All right, that's the horizontal part of our grid. Now let's talk about the other half, the longitudes. If latitudes are the rungs of a ladder, a great way to think about longitudes is to picture slicing an orange from top to bottom. Each one of those wedge-shaped slices is like a line of longitude.
Now, unlike latitudes, these lines aren't parallel. They all meet up at the north and south poles. Their job is to measure how far east or west you are from their special starting line, which is called the prime meridian.
And this is where things get really interesting. The 0 degree longitude line, the prime meridian, was set to run right through Greenwich in London. And this wasn't just a random choice. This line became the starting point not only for location, but for something else we use every day, time.
You see, the Earth spins a full 360 degrees every 24 hours. And that simple physical fact creates this incredible, unbreakable link between where you are on the planet, your longitude, and what time it is. It connects space and time. Let's just do the quick math because it's pretty elegant. You take 360 degrees and divide it by 24 hours. What do you get? 15. The Earth spins through 15 degrees of longitude every single hour. This is the basis for all of our time zones. And we can get even more granular. If you break it down further, it takes just 4 minutes for the Earth to rotate through one single degree of longitude. It's this beautiful, simple math that keeps all the world's clocks in sync.
Okay, so we've got our horizontal latitude lines for north-south position and climate, and we've got our vertical longitude lines for east-west position and time. Now let's put them together and see how they create that perfect global address book.
This table is a really great way to see the differences side by side. You can see latitudes run east-west, but they measure how far north or south you are, and longitudes run north-south, but they measure east or west. And look at the shapes. Latitudes are parallel circles that get smaller, but all the longitudes are the same length because they all run from pole to pole. So here's how it all comes together in the real world. Let's find a city, say Delhi. You just go 28.6 degrees north of the equator, then 77.2 degrees east of the prime meridian. And boom, the exact spot where those two lines cross, that's Delhi. Every single place on Earth has its own unique set of coordinates like this. So you might be thinking, okay, that's cool history, but why does this centuries-old system of imaginary lines still matter so much? Well, the truth is, this ancient idea is the invisible software that runs our modern world. I mean, just think about it for a second. That GPS in your phone, it's just a tiny computer constantly calculating your latitude and longitude. Digital maps like Google Maps, airplanes flying over oceans, container ships crossing the globe, even rescue teams trying to find people after a disaster. It all runs on this fundamental grid.
So the next time you pull out your phone to check a map or get directions, just remember what you're actually doing. You're not just using some piece of modern tech. You are tapping directly into this brilliant, ancient system of global addresses built from nothing more than lines and degrees.
It's really an incredible legacy, isn't it? A system that was designed to guide wooden ships with paper maps now guides satellites in space. Which really leaves you with a pretty cool question to ponder. If this invisible map of space and time built our world, what are the invisible maps we're building right now that will define the future?